here in this course we will read more about the network layers in 2 chapters. The first chapter is about data plan, and the second chapter and the 5th chapter, chapter 5, next chapter, chapter 5, is about control plan. We will talk about these chapters because there is something new in the content of network layer, which is important in the future of computer networks. So we will talk about chapter 4 and chapter 5 in this course. Okay. Here in chapter 4, we try to understand key principles behind the network layer, its services, and some important protocols in network layer. As we talked in chapter 1, the network layer in computer networks is the 3rd layer. Physical, data link, and the 3rd one is network layer. Okay, here we want to talk about the network layer service models, forwarding versus routing, how a router works, addressing, generalized forwarding, internet architecture, and something like that. Talking about IP protocols and how we can use NAT in this layer. Okay. If we look on network layer, in traditional network layer chapters, in traditional network computer network books, you can only see some important contents talking about data plan. But now we have something new in this layer, so we have to talk about control plan in network layer 2. We will talk about data plan here in chapter 4, and control plan will be remained for chapter 5. Okay. Also, we look into a router, into the architecture of a router, its input ports, its switching, its output ports, how it manages its buffer, what is the scheduling in a router. Also, we'll talk about IP protocol or internet protocol, its formats and addressing IPv6, and how we can translate the network access. And our specific guest, SDN and OpenFlow. This is the main and the newest topic in network layer. We have to talk about SDN, software-defined networking. Why? Because it's the future of computer networks. It's the future. So we have to talk about this, how it works, and what is, for example, OpenFlow protocol. Okay. Let me talk about the services in network layer. When we talk about network layer services, as we talked in chapter 1, this layer handles the packet. We put our packets or data or segments into the network layer, and those segments are wrapped into a packet into some packets, and the network layer is responsible to send those packets from the source to destination, from the sender to the receiver. So the network layer is a delivery responsible. Is responsible to deliver packets to the destination. Okay, and as we know, the network layer, look at this picture. As we know, the network layer is presented in the whole devices along the path, in the source, in the destination, and also in the routers. In the routers along the path in different networks. Those routers are responsible to get a packet, check the IP header, find the path toward the destination of that packet, and then modify the packet, the header of packet again, and send the packet toward that destination, toward its destination. It will receive packets from its input port, and it will pass the packets toward its output ports. So, as we said in chapter 1, the network layer has two basic functions. One of them is routing, finding a path from the source to destination. So we need routing algorithms. And the second one is forwarding. Okay, moving packet from one router to another one, passing the packets until the destination. Receiving a packet from a source and passing it, forwarding it toward into the next hop toward this destination of that packet. If I make an analogy, I can talk about finding a path in a troop. I want to go a troop. Okay, so firstly I should find a path, and then I should move along that path toward the destination. Maybe during this path I should pass some big bridges with multiple floors and multiple ways. I don't know. So maybe, but I should be clear about those passes and how I can pass them toward my destination. We can divide a network layer into two different panels, two different sections. The first one is data plan, and the second one is control plan. When we talk about data plan, we talked about the basic functions of a router. We said that okay, one packet will arrive to the router, and router should define its path and forward it toward the destination. Okay. This is data plan. How we should handle a datagram and in an arrival datagram. How we should handle? Finding a path from the source input into the output port, from the input port toward the output port. This is data plan. Handling an arrived packet. But there is another plan, another main and very important plan. We call it control plan. It's a network-wide logic. What does it mean? It means that in control plan, we should know about the whole network, the structure of whole network, okay? And make decision how to handle different packets, datagrams, I don't know, between sources and destinations. So it means that datagram, it means that control plan is about routing. We should define a route for the arrival packets. It's something about control actions in routers. As a user, I never think about that. I don't care about them. The network should find a path for my packets. How? I don't know. I'm not care about them. But the ISP should be care about that. The administrator should be care about that. How we can find those paths? Okay, simply we can use traditional routing algorithms. For example, OSPF or RAID, EIGRP, ISIS, I don't know. There are several routing algorithms in network nodes. We can use them. But to date, we can use software-defined networking or SDN. I told you, this is the future of computer networks. In SDN, in traditional routing algorithms, a routing protocol is started on each of routers individually. Each router has started its own routing protocols to find the passes around the network. Okay? Each of those routers will do this strategy. But in SDN, in a state of routers, we have one or two servers in the network. That servers will think about the passes, the routes in the network. That servers. Okay. We will talk about SDN in the future. But now we can say that in traditional algorithms, each router will run a routing algorithm, something like this. We have several routers in the network, and each of them is running a routing algorithm per router. Okay, each of them runs the routing algorithms, and the results of those algorithms. The result of those algorithms is saved in a table. We call it forwarding table or routing table. So a routing table is a result of a routing algorithm. Finding routes in a traditional computer networks. But as we said, in SDN or software-defined networking, those routers in the network just think about finding a path, finding a route using a table, a forwarding table or a routing table. But here, the control plan is shifted into some servers. Those servers think about the routes, about the passes, finding passes. Those servers. What does it mean? It means that in the future routers have not control plan. Their control plan will be shifted into some routers, some servers. And those servers think about the passes, and then their result will be returned to the routers, to our routers. And our routers just consume the results. Why this is important? Because I can assign a simple server into my network and run the SDN server in that server. And then, instead of having a complicated router, I can have a simple router. Why simple? Because it does not think about too many things. Just it needs to think about forwarding. Even here, in the control plan in this remote servers, I can think about, for example, secure routing, a routing with quality of service, a routing with backup routes, everything. Using this strategy, I can handle my traffic clearly with complete control. It's different. I will check. I never think so, because these slides are version 8 of the slides are version 8 of the book. I will check it. Okay. Oh, I will prepare a link for you, but be clear. In that link, you can see slides of the 7th edition of the book and slides of the 8th edition of the book. No. Be clear about this. I'll prepare a link for you, a download link for you. Okay? In that download link, if you go, you can see a web page. In that web page, you can find slides of the 7th edition of the book, and also there is an extra link to the slides of the 8th edition of the book. Here I'm using the 8th version, 8th edition of the book, not the 7th one. If you see these differences, please check the download version. Look at this here. Look at this. These slides are slides of the 8th edition, not the 7th one. Okay. Okay. Cool. Okay. When we think about the service model of the network layer, we can say that the network layer prepare a channel to transport my datagrams from the sender to the receiver. This channel will try to deliver the packets or datagrams to the sender. Okay? But maybe someone say, okay, can it guarantee this delivery, or can it guarantee the delay between the source and destination? I should say, okay, it depends. I will ask you why it depends. But it depends. In IP version 4, we cannot guarantee these items, but it depends. For example, in virtual circuit switching networks such as ATM, frame relay, or X25, yes, we can guarantee, but in simple or IP-based computer networks, we cannot guarantee in these items. Okay. But if you look for those guarantees, we can look for something else. For example, instead of talking about individual datagram packets, we can talk about a network flow, a traffic flow. A traffic flow is a combination of some packets. Those packets have similar source and destination. Okay, a flow is a collection of packets with similar source and destination. So those packets should be sent into a similar path. It's completely clear because their source and destination are similar. So simply we can say, okay, send them and if I send them into a similar path, so I can guarantee that those datagrams will arrive to the receiver in order. And also I can guarantee a minimum bandwidth for flow and make more restriction on sending those packets. Okay, so remember this word flow or traffic flow. Remember this, we will talk about it in the future. Look at this. In today's IP-based network, when we talk about a datagram network or when we talk about a packet switching network, a packet switching network something like internet acts its service model is best effort. It means that it will try according to its power. It will try to do. And inshallah, your packets will arrive to the destination. Inshallah. Okay? It means best effort. So we have no guarantee on successful delivery. We have no guarantee on time of delivery. We have no guarantee on bandwidth availability. We have no guarantee. Okay. So when we talk best effort means inshallah. We will do something, inshallah, we will receive a good result, inshallah. Okay. So here, in a best effort system, we never guarantee the bandwidth, the loss rate, the order between the packets, and timing. We never guarantee these items. Cannot find some slots? Why? Can you see this one? Naima, can you see this on slide 411? Oh, you mean that you cannot find the slides from different chapters? I will upload all of them for you in the WhatsApp group. I will upload all of them. Don't worry, okay? Okay, so when we talk about internet, we can see that the internet can guarantee nothing. But what will happen if I need something? Some guarantees. I will send it. Okay, I will send it. For example, let's suppose I have using ATM technology. ATM is a virtual circuit switching technology. ATM is a network with virtual circuit switching technology. Look at this. ATM has several services, several service models. For example, one of them is CBR, or constant bit rate. It means that it will guarantee a fixed bandwidth. So I can send a constant, I can send my data with a constant rate. It will guarantee the loss rate, order, and timing. Or for example, ATM has another service model. It's available bitrate, or ABR. It will guarantee a minimum bandwidth and order between packets, but it won't guarantee the loss and timing. ATM has 4 or 5 different service models. Here you can see only 2 of those service models, okay? But you can see ATM can guarantee some things. It depends to your requirement. We can use those service models, okay? But for example, today's, if we use integrated services or IntServe, or if we use DiffServe, we can guarantee some items in computer networks. For example, if we use int serve, we can guarantee the bandwidth, loss, order, and timing over the internet. We said that the internet, the basic of this internet is best effort. So I cannot guarantee. I can guarantee nothing. Okay? But if I use int serve, I can guarantee everything over the internet. Or even if I use diff serve, possibly I can guarantee some items. Yes, Naima. Naima said that, okay, ATM is it transportation technology in telephone communication companies? Yes. We have two different ATMs. One of ATMs is, you can see one of those ATMs in banks. It means automatic teller machine. Teller is an employee in bank who pays the money. Okay, ATM in bank is automatic teller machine. This machine pays money to us. Okay, but here ATM is for a synchronized transfer mode. Is a telecommunication technology. We can see this technology in telephone companies. Yes. But it's absoluted. ATM is absoluted. Most of telecommunication technologies are absoluted in today's. Okay? So, again, our internet is a best effort service. Why? Because in internet we very look for a simple mechanism to transfer data over the internet. Just we need to simple transmission mechanism. Okay? If you look on telecommunication networks, telephone telecommunication networks, they are very complicated, extremely complicated. But the best effort service of internet of IP, it's very easy, very easy. You can develop it widely. But if you need to guarantee some parameters, for example, guarantee the bandwidth for this application, this Adobe Connect application. We have some strategies, some methods such as int serve or diff serve to provision a bandwidth, a sufficient bandwidth for a user, especially when the users need some guarantees when they are working with real-time applications such as interactive voice, videos, distance learning, and something like that. Okay. So in internet, we try to be good enough. For the most of times, we try to be good. We never guarantee internet. We never guarantee those items, but we try to be good enough. And by distributing the contents among different data centers or different content provider networks all around the world, we can see the distance between the source and destination, between me and the server that I'm looking for that. This all distance will be short. I can receive the services from different locations. Okay. In today's network, the ISPs and the content provider networks try to be close to the users, to remove long distances between them and their users. Okay, and also we have congestion control mechanism, different congestion control mechanism to application who has elastic behavior. Elastics means that those applications can tolerate some delays, some packet losses. We can tolerate some bad news, something like this, such as this. Okay. But still, we care about this. But still, it's hard for us to argue with the success of base effort service model. It's hard. It's try to be good, but nobody can guarantee this. We care about this. Okay, that is enough for today. Is there any question? Any question? Okay, thank you. I wish the best for you in the rest of this speech, and goodbye.